Hello everyone. Today's topic is about a very basic thing that I think is really important to understand, and uh, understanding it is one thing, but to actually correct someone and to find that someone is making a bad assumption or coming up to a bad conclusion based on these two uh, these two topics is really important. So the point that I'm trying to make is that correlation does not guarantees causality. Now let's just define what causality and correlation is. So causality, basically in causality, let's say we have two events. We have event 1 and then we have event 2. Event 1 is the causing event. This event 1 happens and then the event 2 is caused. So event 1 is the cause and event 2 is the effect of that event. After the So this is causality. Now how correlation works is, let's say we have in mathematical terms we have two variables. We have x, we have y, and when x rises, y falls down, or maybe when y goes in an hyperbola, then x goes in some other state, some other mathematical state. So basically x and y are mathematically correlated, or fundamentally correlated due to something, but that does not guarantee the fact that x is causing y or y is causing x. Now what a lot of people struggle with is that causality in and of itself is, I think, a subset of all the correlations possible. Suppose we have a set of events that we are talking about. Let's say we have 10 events that we are talking about, and we develop some kind of relationships between those events, and all those relationships that we have developed are almost all of them would be correlations. But after we have developed the correlations, some of those events, a subset of those events, would be causal events. Again, to give you guys a more concrete example of this, a causal event would be that you did not study, because of you did not study, you got bad grades. This is a causal event. Now a correlation would be that you are getting scolded by your parents. So you got scolded by your parents, and uh, another event, again you got scolded by your parents, and now you are sad. Again, you can be sad due to a lot of other reasons. uh, it is not guaranteed that you are sad because you got scolded by your parents. Those two events are correlated but not directly, to put it in correct terms, causal, because sadness does not always guarantee that you are going to, again, scolding does not always guarantee that you are going to be sad. So I hope that this video shines some light on uh, when uh, when an event is causal, and when an event, not an event, but actually two events, or a relationship is, when a relationship is causal, or when an when a relationship is correlated. um, Again, I cannot really come up with any other neat examples to explain you this concept more, but with all of that said, I hope you learned something new from this video, and I hope that you will be able to differentiate between these two without any problem. Again, don't be super sad, or don't start judging yourself that you are not getting this, because a lot of times two events may look causal, but upon further inspection you may find that no, they are just correlated, and you start finding a chain of event, and in that chain of event you find that there were further events down the road, and those two events were, again, let's say there is event A which is causing event B. Now first of all, you come to the conclusion, if event B is getting caused because of event A, then they must be causal. But then you start inspecting, you start going down the rabbit hole, you start seeing that okay, no, between A and B there are multiple more events. We have A1, we have A2, we have A3, we have A4, and when you discover this sequence of events, you find out that okay, these events are definitely correlated, but uh, they are not guaranteed to be causal. They are most probably correlated and not causal. So I hope you learned something new from this video. And one more thing that I would like to say is, I don't think it is always possible or technically possible to guarantee that two events are going to be causal. I mean, cause and effect can be, you know, we can say with a reasonable amount of certainty that this event B is being caused by this event A, but we cannot guarantee the fact that this event B will definitely always be caused when the event A is going to happen. Because again, everything that we are predicting is based upon past experiments. Now past experiments can have errors, and those errors can cause problems such as this one. uh, Again, this was all for this video. I have nothing more left to say.